Good morning to everyone. I'm Serena Sorrentino, and my advisor is Professor Sonia Bergamaschi, and my co-advisor is Professor Sandra Baggio from the University of Texas in Dallas. The title of my presentation is Label Normalization and Lexical Annotation for Schema and Ontology Matching. Okay, let's start the presentation with a brief overview where we are going to introduce and to define the main concepts related to my research activity. First of all, what does it mean schema matching? Schema matching can be defined in general as the process of finding the semantic correspondence among the elements of different schemata. Thus, a schema matching system, also called the matcher, receives as input two heterogeneous schemata, in this case S1 and S2, and thus it may use the schema information such as the names of the elements, data types, constraints, so on. It may use during the schema matching process also auxiliary information such as dictionaries, thesaurus, or glossary, and so on. And when available, it may use also instance information. The output of a schema matching system of a matcher is a match result which is composed by a set of mapping elements specifying that certain element of the first schema correspond to certain element of the second schema. The key idea of the DB group, which is the research group of which I'm a member, is that starting from the hidden meanings associated to schema labels that are the names of attributes and classes, we can discover lexical relationships among the schema elements. In order to explicit the meaning of the name of classes and attributes, we need to perform a process called lexical annotation. Lexical annotation can be defined as the process of explicit assignment of meaning to schema labels with respect to a reference lexical thesaurus, that in our case is the well-known lexical database WordNet. From lexical annotation, we can discover lexical relationships. We identify three main types of lexical relationships. A synonym relationships, which is defined between two terms that are synonym. A BT, broader term relationship, which is defined between two terms where the first generalizes the second, and the opposite of the BT relationship is the NT relationship. And finally, a related term relationship, which is defined between terms that are usually used in the same context together. Moreover, we can automatically extract from the structure of the schema-derived relationships. In particular, for example, we can extract BT and the opposite NT relationships from ISA relationships in ontologies, and RT relationships from nested elements, for example, in XML files. Let us consider a very simple example where we have to annotate two schema labels, customer and client. This label have in WordNet, customer has only one meaning, and client has three different meanings. To perform lexical annotation, we need to manually select the correct meaning for these labels in WordNet. In this particular case, we select the first meaning for customer and the first meaning for client. The strength of a thesaurus like WordNet is that it provides a wide network of semantic relationships among meanings. In this case, as the first meaning of customer is a synonym in WordNet of the first meaning of client, we can derive automatically derive a synonym lexical relationship between the schema element customer and client. Moreover, we can derive a BT and the opposite NT relationship from a hypernym and hyponym WordNet relationship, and an RT relationship from a meronym relationship, and when two meanings are siblings in the WordNet hierarchy. The lexical annotation and lexical relationship discovery process have been implemented by the DB group in the MOMIS data integration system. The goal of a data integration system is the construction of a global schema starting from a set of independently developed data sources. Thus, the first step of a data integration system is the wrapping phase. During this phase, we are going to automatically extract the schema from the local sources. After, the second phase is the lexical annotation phase that in the first version of the MOMI system was performed manually by the integration designer. After that, the third phase, the common thesaurus generation phase, where we are going to collect within the common thesaurus component lexical relationship, schema-derived relationship, potential user-supplied relationship, and finally, MOMIS is able to infer further relationships starting from the ones previously described. By exploiting a cluster generation process, MOMIS is able to create the global schema, which is composed by a set of global classes that represent similar local classes, and from a set of mapping tables that contain the mappings between the global and the local classes. Finally, the global schema is automatically annotated with respect to WordNet, starting from the annotation of the local schemata. The main drawbacks of manual annotation is that it is a time-consuming, boring, and not scalable task. As a consequence, we need to study and to develop a method to perform automatic or at least semi-automatic lexical annotation. Let us consider a simple example where we have to integrate two schemas, a relational schema and an XML file, the schema extracted from an XML file. In order to perform automatic or semi-automatic lexical annotation, we need to address the problem of the presence of non-dictionary words in schemata. These non-dictionary words may be abbreviation, compound nouns, acronyms, and so on. These labels cannot be directly annotated, automatically annotated, as they don't have an entry in WordNet. As a consequence, we need to study a method to perform schema label normalization. Moreover, fully automatic lexical annotation is intrinsically uncertain. Thus, we need to deal with the problem of uncertainty in automatic lexical annotation. Okay, now we are going to describe in details the single method I proposed and studied during my PhD in order to address the problem previously described. First of all, in order to perform automatic or semi-automatic lexical annotation, a method for word sense disambiguation has to be devised. Navigli defines word sense disambiguation as the ability of identifying the meanings of words in a context by using a computational technique. During the first year of my PhD, I have taken part to the development of a combined word sense disambiguation algorithm, which is a semi-automatic method which is able to annotate schema label with one or more WordNet meanings, and which is composed by two main word sense disambiguation algorithms, SD and WND. SD tries to annotate labels by exploiting the schema-derived relationships. The WordNet domains disambiguation algorithms exploit the external resource WordNet domains. Okay, this picture shows the lexical annotation process performed by CWSD. We start by extracting by using automatic wrapper the schema label, thus the name of classes and attributes, and that together with the schema-derived relationships represents the input of the method. CWSD executes first the SD algorithm and after the WordNet domain disambiguation algorithm. In particular, during the last one, the integration designer selects the relevant domain for the schemata, for example, commerce, business, and so on. The output of the method are the local schemata annotated and the set of lexical relationships which are collected together with schema-derived relationships in the common thesaurus. CWSD has been evaluated over a real data set in particular the directories of Google and Yahoo. And the experimental results shows that it was able to obtain good performance, but in particular it was able to outperform the results of the single algorithms. The second problem I addressed has been the problem of schema label normalization. As we have seen before, in order to perform automatic annotation, we need to deal with the problem of non-dictionary words. To do that, we need to study a method to perform schema label normalization that in general can be defined as the reduction of each label to some standard form that can be easily recognized. In our case in particular, we define schema label normalization as the process of abbreviation expansion and compound noun annotation. Schema label normalization helps to improve schema matching by reducing the number of false positive and false negative relationships that we can discover between schemata. Let us consider this simple example where we have to integrate these two schemata, PO and purchase order. Without normalization, we discover, for example, a false positive relationship between customer name and client address. As we have seen before, customer and client are synonyms in WordNet. Moreover, without abbreviation expansion, we are not able to discover that exists a synonym relationship between the label, for example, amount, and the abbreviation of quantity. On the contrary, by applying a normalization method, we will be able to discover only the correct relationships. Thus, we proposed a schema label normalization method, which is composed by three main phases. The first phase is label preprocessing, where we are going to select the labels to be normalized, to tokenize the label in single words, and finally to classify these labels in compound noun, abbreviation, or compound noun containing abbreviation. The second phase is the abbreviation expansion phase, which has been the focus of the research activity of the PhD student Maciej Gawineski, and as a consequence is not the focus of my presentation. On the contrary, we are going to describe in detail the last phase, that is the compound noun annotation phase, that consists in the interpretation phase of compound nouns, and we are going to annotate a new compound noun by creating a new meaning in the WordNet thesaurus. Some definitions. What is a compound noun? It is a term that is composed by two or more words called the compound noun constituents. The great majority of the English compound nouns falls in the endocentric category, where an endocentric compound noun is characterized by the head modifier structure, where the head has the basic meaning of the whole compound noun, and the modifiers restrict the meaning of the head. For example, for the compound noun delivery company, the head will be company and the modifier will be delivery. The method is divided in 4 steps. The first step is the compound noun disambiguation, where we annotate the head and the modifier with respect to WordNet by using CWSD. The second step is the redundant constituent identification and pruning. What is a redundant word? Is a word that does not contribute with new information because its semantics can be directly derived from the schema or from the thesaurus. For example, it's common practice in relational schemata to report the name of a class in the name of its attribute. For example, for the class company, the class company may have as attributes company name, company address, and so on. As a consequence, the modifier company, in this case, will be a redundant word. The third step is the step of compound noun interpretation, where that is the selection among a set of predefined semantic relationships that in our case is are the nine semantic relationships proposed by Levy. Select the ones that best represent the relationship between the head and the modifier. Our intuition is that the semantic relationship that is holding between a head and its modifier is the same that is holding between their top concept in the WordNet hierarchy. These top concepts are the 25 unique beginners defined by the creator of WordNet, and start by manually selecting the correct relationship for the couple of unique beginners. We can automatically infer the interpretation for all the other compound nouns. We decided to use the Levis relationships as they are suitable to interpret very general concepts as the unique beginner. Moreover, in a simple context like schema ontology matching, a very detailed interpretation of compound noun is not required. And moreover, the name of the relationship can be directly used during the next step, that is the creation of a new WordNet meaning. This is a very simple example where we can see that for the compound noun delivery company, if we select the Levy relationship make for the unique beginner, by navigating the WordNet hierarchy, we can automatically infer the same relationship for the compound noun. The last step is the creation of a new WordNet meaning for the compound noun in order to be able to annotate the compound noun. Thus, we are going to create the gloss, that is the definition in words of the meaning, starting from the glosses of the head and the modifier, and by using as conjunction the Levis relationship previously selected. Finally, we are going to include the new meaning, the new gloss, within the WordNet hierarchy. In particular, we create an hypernym and the opposite hyponym relationship between the new meaning and the meaning of the head, and a related term relationship between the new meaning and the meaning of the modifier. The schema label normalization method has been evaluated over 5 different real data sources, and we evaluated in particular the performance of the lexical annotation process without and with our method. As we can see, we are able to increase recall without significantly worsening precision. But what is relevant is that during the lexical relationship discovery process, we are able to improve significantly both precision and recall, and as a consequence, we also have measured that is a combination of precision and recall. The last problem I addressed is the problem of uncertainty in automatic lexical annotation. We represent uncertainty in automatic lexical annotation in terms of probability. I've taken part to the development of a probabilistic word sense disambiguation method that is able to annotate each label with one or more meanings of WordNet, but is able also to assign to each annotation a probability value that represents the reliability of the annotation itself. It is composed on a combination of different word sense disambiguation algorithms, and the single results are combined by using in a probabilistic way by using the Dempsey-Schaffer theory of combination. This is a very simple example where we have to integrate two ontologies. We are going to extract the schema label, which represents the input of each word sense disambiguation algorithms. To each algorithm is associated a confidence value that represents the reliability of the word sense disambiguation algorithm. The single annotation, the single results are combined by using the Dempsey-Schaffer theory combination, and finally we obtain a set of lexical annotation that are probabilistic, as to each annotation is associated a probability value on the basis of the confidence of each algorithm. Starting from probabilistic lexical annotation, thus we can discover probabilistic lexical relationships. The probability that will be assigned to each relationship is computed on the basis of the probability of the single annotation. This picture compares the relationship that we obtain by using a very simple heuristic, the WordNet first sense, that is the standard baseline to evaluate each word sense disambiguation algorithm in literature. And as we can see, by using our method, we obtain more relationships, and we obtain not flat relationship, but probabilistic relationship. Thus, we can improve the probabilistic result, for example, by applying a threshold in order to filter the relationship with a probability under a certain threshold. Also, PAWSD has been evaluated on relational schemata and on ontologies. It was able to improve recall with a little decrease of precision, but for the lexical relationship discovery process, it was able to improve significantly recall and, as a consequence, F measure. All the methods I presented have been implemented in tools. Norms, schema label normalization functionality has been implemented in a standalone tool called Norm, Normalizer of Schemata. And the CWSD and the PWSD have been implemented in a tool integrated within the MOMIS system called ALA, Automatic Lexical Annotator. To conclude, I presented methods, automatic and semi-automatic method to perform lexical annotation. I present the automatic method to extract probabilistic or not lexical relationship, and their effectiveness has been shown during the experimental results. All the methods have been implemented within the MOMIS that evaluated in the context of the MOMIS data integration system, but they can be applied in general in the context of schema and ontology matching. Future work will be devoted to the study of technique to integrate new knowledge resources, for example, domain-specific resources, in order to address the problem of the present in schemata of domain-specific term. This is a very simple example, the biomedical term aromatase. And moreover, we can try to exploit also other generic resources like Wikipedia. Finally, another interesting future direction is the inclusion during the automatic lexical annotation process of the information deriving from the data, the instance information. For example, the use of the tool Relevant, which is a tool realized in collaboration by the DB group, represent a promising direction in order to address the problem of non-informative schema label. What is a non-informative schema label? Is a label, for example, is a code. We cannot derive the semantic of a code from the label. We need to discover the data. We need to have a look on the data. These are my publications. The project that had support in my research activity, and the bibliography, that's all. Thank you for your attention.